Welcome everyone to this afternoon's keynote by Dr. Laura Castro. She's going to talk to us about 12 years supporting software architecture teaching with Beams. And we're very happy that she could join us today. Without further delay, over to you.
So thank you for the introduction. And of course, I want to extend the thank you not only to the people in the organization that are actually in this session helping me out with everything, but to the whole team. I know that putting together an event like this, a two-event online event, it's really hard work, and it's really not visible unless things go wrong. So when everything is going great, you don't notice them, but there's a lot of effort there, and I'm thankful for all their work during the upcoming months up to this point, also for inviting me, being here, talking about two of the things that spend many of my hours every day, which is teaching and functional programming, but in a combination that is not really typical. So we hear a lot about teaching FP in the context of programming courses or programming experiences, bootcamps, and the like. But here I will be talking about functional programming and teaching functional programming, not as an end, but as a tool in a completely different context, in the context of software architecture. So let's go. As the introduction said, I'm Laura Castro. I'm software engineer by formation, by studies. Did later on a PhD in computer science. I am a professor nowadays. I teach software architecture, among other things, but this is the context that should interest us today. I'm also a researcher, so when I'm not teaching, I try to be in contact with industry, and specifically the part of our industry that uses FP, and see what kind of challenges they have, what kind of tools they need, and I try to work in that fruitful connection that has always bring me a lot of interesting problems to look to. And well, finally, I consider myself an advocate for women in tech, for gender perspective in general, and also of free software. But from all this, probably the most relevant thing today is that I'm part of the Education, Turning, and Adoption Working Group of the Erlang Ecosystem Foundation. If you've been here today, yesterday, you've probably watched one or two talks about colleagues that are part of this Erlang Ecosystem Foundation initiative. We will probably talk a little bit about this further down the talk. So let me start with a little bit of a tale. So once upon a time, the title already gave a little bit of a spoiler, because we're talking about something that has happened for the span of 12 years. So if you go to the beginning of that span of time, almost, well, a little bit of more than 10 years ago, in June 2014, I was in Stockholm giving a talk which title was Erlang as Supporting Technology for Teaching Software Architecture. I was more or less a fresh PhD graduate at the time. I had been commissioned with designing a software architecture course for the first time. And you can imagine my hope at that moment was to be able to use FP for lots of things, also for this new assignment that I had at the time. And the goal was that. So can I do this with Erlang, which is kind of the language that I've been working for a number of years, and the one that I'm most passionate about. And I tried to rationalize, to make it rational, like a decision that, yeah, I do want to do this, but there are a number of reasons that make this like a promising path, right? And I will do a little bit of a spoiler alert, because I'm not going to repeat exactly the same talk, of course. And that was an experiment, right? So I set it up an experiment to see if that was possible, if Erlang could be a tool, a meaningful tool for this goal that I had at hand at the moment. And for those in the audience who might not be as familiar with Erlang as others, just a brief a brief debriefing of the language. Is a rather established language by now. It was born in 1986, released as open source in 98. It's functional, of course, but the main trait of the language is concurrency orientation. Again, if you've been like yesterday in Robert's talk, who gave a wonderful history overview of how the language was born and evolved and its influences, then you already know all this. And if you haven't, then take the time to watch the video afterwards, because it's really worth it. So what this concurrency orientation means is that it helps you to think about your systems in terms of small language processes that are completely isolated. They share nothing. They communicate through message passing, and that forces you into a particular mindset, right? And also it has some other advantages, like Beam, a language that is executed on a virtual machine that nowadays is multi-platform. So it gives you as a bonus the fact that your system is going to be able to run in different operating systems and hardware without you making a fuss about it. You don't have to worry about memory collection or anything. There's garbage collection for you. There's hot code swapping, which is really interesting if you're thinking of long-living systems in production. And also, distribution is really made easy for you. So you can really set up different virtual machines, connect them very, very easily. And the process living in those different nodes, in those different virtual machines, communicate regardless of where they are in the same way. So it's transparent to you as a programmer, wherever the other process that you're communicating with is. So that's the kind of short overview. And well, the thing with the Beam is that the source code is compiled into a binary format, which is the one run by the binary virtual machine, and those files are .beam files. So that's where the Beam surname comes from, and the reference that we all in the community use once and again, even nowadays, to refer to ourselves as the Beam community, right? So the experiment was a success, and that's the spoiler. And I've left the link. I put the link there on the slide in case anyone wants to see how 10 years ago I talk about the experiment, and the slides will be later on speaker deck and SlideShare, so you will be able to find them, I hope. But the thing is, okay, you're talking about a decade-old talk, right? So how is it relevant nowadays? Why should we care about something that you set it up 10 years ago in 2025? Well, let me remind you that I'm an academic, right? So yeah, we as part of the scientific part of our job, we do experiments, but experiments are nothing but experiments unless you demonstrate that you see that they are repeatable, that they hold the pass of time, right? So the question here is, did the experiment resist the pass of time? What happened during this time? Did the beams resist the pass of time? That's the question that I wanted to answer with you here today. So let us have a little bit of context so that we can really understand what this course on software architecture is and the role that FP played in that experiment, and if it held their grounds up until today. So you can take a moment to find yourself in this world map, wherever you are, even either today following the live stream, or in a number of days or months from today, if you're watching this when it's recorded. Myself, I'm in that blue country that you can find now on your right-hand side. So the blue one is Spain, the orange one is Portugal, and the two together form what we call the Iberian Peninsula in the southwest part of Europe. And in particular, I'm in the region of Spain, which is right on top of Portugal. So the part of the blue country that sits on top of the orange one. And the funny thing is that we actually have a lot of common with Portugal, for historical reasons. We even have a language which is really close to Portuguese. So that's where I am, and the city I am is called A Coruña, and the university I teach in is called the same, University of A Coruña. Is a small town, like 150,000 people, and it's not full of students. There's not the kind of city that you go on and you immediately feel that you're in a university city, so to speak. In the early 20s, which was the peak of students that we had 25,000 students in the whole university. It's a relatively young university. So in Spain is, as in Europe, we have a handful of universities that are more than 500 years old. But the University of A Coruña is relatively young. And it was funded because there were a lot of like careers that were not present in those old traditional universities, but that they were demanded by the society. And informatics, computer science, computer engineering was one of them. And it's actually the largest faculty in the university up to date. And we have like around 2,000 students all year round, right? We also have, which is not that common, so many universities, when they have graduate or undergraduate CAs related students, they focus on one of the 5 branches of the computing curricula that ACM has, well, sort of outlined for us worldwide. But we do have the 5, right? So in A Coruña, someone who wants to get into computer science, they have 3 years that it's common knowledge, and then on the last year they have to do an intensification on one of these 5 sub-disciplines. And this is relevant because software architecture is not relevant, it's not central to the 5 sub-disciplines, but only for software engineering and computer science. So not all of those 2,000 students come to my courses, thank God, because otherwise I would be I would need many more teaching assistants. And the course, well, as you can imagine, given that I did the experiments like 10 years ago, it was first taught in 2012, 2013. So when I talk about this in Stockholm in 2014, it was like the second year that I was doing that. It runs twice a year, so once every semester, and it's 15 weeks. I have 3 weeks of lecture, so it's usually 1 hour and a half of traditional lecture and 1 hour and a half on the lab with the computers doing hands-on stuff. But then every student is supposed to put in personal effort for between 7 and 9 hours a week on top of that, so that at the end of the semesters they have the effort that is supposed to be necessary to grasp all the concepts on software architectures. And this is, as I said, compulsory for software engineers. Computer scientists may or may not choose this course, but they have the options, and the others, they do other stuff. And this amounts for between 60 and 80 students per year for me. And what I try to teach them, what are my learning objectives for them, is first of all, they have to really understand why they are there. So they've been studying programming for a number of years. They already have had some courses on software design. So they kind of acknowledge that you just cannot sit in the front of your IDE and start programming. You have to think about what you want to do with the software, what are the functionalities, and design your components on different parts of your systems. But sometimes they usually have not had the time to think what is beyond design, or rather the fact that when you're thinking about what the software has to do, which is mainly what you do on the design phase, you focus on functionalities, but there are a whole new world of non-functional requirements. So how robust your system has to be, how resilient it has to be, how available, how performant. So those how the software has to behave rather than what it has to do complements what they have been doing so far. So the first sessions is about them realizing that there's something missing in what they already know, that there's actually this higher level stage of thinking about the architecture of a sometimes larger, sometimes not, but it's an additional thinking layer that you have to put on top of that so that really your product will be successful in the future. So once they've acknowledged that, we study a number of reference architectures. And sorry, I try to avoid the word pattern there because it's overloaded for them as a design pattern, right? So I talk about styles, architectural styles, and of course we go from layers and microservices to pipelines and microkernel and peer-to-peer and leader worker and you name it. And we also kind of unmask the new names because I mean, we're all software engineers who have been in the technology world for a while, I guess. And so we know that from time to time, new names for old ideas appear. So we kind of demystify a little bit also the new architectures that come from time to time, which are like old ideas with new names, right? And that's kind of the core of the course. And then there are a few notions on components design, integration, and also testing. But from with those two first points, they have like the strong part of the course that they then have to put in practice, because it's not only hearing about it, but it's also working with it and see what that means. So for you to picture, what I want them to really grasp is, imagine that you have a system and you can actually configure how you architecture the system, your components, your dependencies between them in a number of ways, depending on what you want to achieve. So I want them to really experience not only what it means that if you use the topmost, the top center architecture, what happens if A is down for a while, as opposed to using, say, the one that's next to the right, right? So I really wanted them to be able to see what happens, to experiment, so to get components down and see how hard it is that the system continues in operation or gets back to operation, or what happens if B is suddenly much more slow than anticipated, or things like that. And for them to do that, they have to actually implement things and break them and see how they evolve and actually realize. So what's the role of FP and Erlang in all this? Well, for me, and that experiment was a rapid prototyping tool. So the capabilities of Erlang as a languages and the Erlang VM and the Erlang ecosystem, OTP libraries and stuff, is helping them doing that implementation in a much faster and meaningful way than in other languages that I knew at the time and that I still know today, right? So that was the experiment. And how it works is that we have like the first 3-4 weeks of getting to know the language, and that matches that part of the syllabus in which I'm convincing them that the architecture is really meaningful. So that's kind of the timetable, right? They learn about the syntax and they do some simple exercises with small processes or lightweight processes in small tasks, right? So once they have the two and we've started to know a few architectures, then they have to form large groups, 5-6 people, and they have to choose one project. And that's all their idea. They think, well, I want to do, I don't know, a sport item shop, or a distributed video game, or board game, you name it. They have thought of awesome things in these 10 years. But the thing is, they choose the problem, they choose the functionalities, and they commit to the non-functional requirements they really want to give their system. So if they're designing a board game, Should the game be able to continue if half the players are down? Well, they have to really be meaningful and specific about what they want to achieve. And then, of course, they have to choose an architecture for that and implement it in Erlang and do a demo at the end of the term. So that's the thing. And that's what I called a success 10 years ago. So let us fast forward to today. What happened? What do you think happened? Did the experiment resist the pass of time? So I am expecting you to be really, really wondering and to be really, really wanted me to ask or to answer. Do you still use Erlang in your class, in your software architecture class? And the answer is no. Oh. But hold your horses. Do you still use FP? That would be another way of asking. And happily, the answer here is yes, yes. I never stopped using functional programming for this course. So what happened was that I use Elixir nowadays. So that was a change that happened in the course of these 10 years that I did apply. I changed the language. I didn't change the ecosystem, as you can say, as you can see, but I did this upgrade in 2018, 2019. So I was like 5-6 years using Erlang, and we will talk a little bit about Elixir now. But by then, so after 5 or 6 years, I was happy with how I had designed the course and how useful Erlang was demonstrating to be as a rapid prototyping tool. But I had also been watching closely this new language that had appeared in the ecosystem. And I finally did the change in 18, and I stuck with the change up until today. So Elixir. So Elixir is another functional programming that also runs on the Erlang VM, on the same virtual machine. So it was first released, well, exactly at the same time when I was commissioned to design this software architecture course. But of course, early adopter as I am in many things, I had to be a little bit cautious, right? So at the time, I chose the language I was confident on, I had been using for a number of years. But and this is an argument that you probably heard. I think it was mentioned yesterday by Brujo and also by Robert and probably Alvaro in his talk about the BIM as well. Well, programming language syntax is a very personal thing, I would dare say. So some people consider that Erlang syntax is kind of old or strange. It looks like things that we don't really use a lot, like I don't know, Lisp or well, whatever. And Elixir coming from José Balin, which was a really important player in the Ruby community, which, well, allegedly is much more modern, but has this fresher air to it, so to speak, right? But what was more important to me, and the reason why I was following very closely the language from the beginning was the community that was the sub-community that formed around it, that was really, really focused on welcoming people, was really, really focused on making it easier for newcomers, for people wanting to really know the language. And there were lots and lots of learning resources from day one, very high quality resources. And also quite some effort on developing not only the language itself, but a whole set of libraries that will help people getting up to speed. Same as you do, say, if you're developing in Java, there are lots and lots of things that you will never think of implementing yourself. The first thing you do is you go and find the library that I'm sure it exists for problem X. Well, the same or kind of the same feeling was for me at the beginning, from the beginning, at the center of the Elixir growth, right? So the same effort of, well, this is a typical problem. There must be a library for Elixir that does that. And that feeling held up until today. And of course, being on the same ecosystem, it also means that you can use the libraries that you already knew if you already knew Erlang. So that was a bonus as well. So that was the little brother that appeared in the Bean community. And after a number of years, and when these two traits really held up that test of time, I decided to make the change. And I dare say that probably Elixir was kind of an inspiration and a model for many other young siblings that we have welcomed into the Beam family through the years, because there's not Erlang and Elixir alone anymore. There are a number of languages nowadays on the same virtual machine with the same concurrency orientation feeling and core, if you will, right? So at the end of the day, and if someone teaching software architecture but with a love for any other language flavor out there is ever watching this, I would just say, go and check if there's a flavor of your favorite language on the Beam nowadays, because chances are there is, so that you can adopt it for your teaching. So the beams did resist the bus of time. That is the good news. Things that stay the same and that changed. Well, I have experienced that it was true that the resources and the documentation were easier on students. That I have seen in this since I have adopted Elixir for my course. That makes some things with the languages a little easier for them. They are more autonomous. They can solve more problems with their own learning at the beginning, but they still have to force themselves beyond object orientation, as I put there. That was true with Erlang and still is true with Elixir on the course. And it's not so much about the functional programming, the thing that we say a lot about recursion and side effect free, and you have to think differently. That is true, but I think it's not the core. In the context of software architecture, I think what hinders them the most is synchronicity. So they come from the object orientation world, most of them, meaning that in the 2-3 years before, they have worked a lot with Java, sometimes with .NET, with Python stuff. And they are very used to inheritance and delegation and composition, and that sort of way of thinking about your programs and the workflow of your programs. And it's, for me, it's a very synchronous way of thinking about software and software that is going to solve problems in real life. And that is the most difficult part for them. So, and it's the most critical thing for them to really grasp what different architectures are about, and what the upside of choosing LeaderWalker before, I don't know, microservices, or peer-to-peer before pipeline. You have to really understand that you have different components in your system doing things at their own pace, and you may need from other component whatever, but it's not for you to decide what the other component is going to give you to you, right? So that is the most critical part. And as I said, that's not really related to the programming paradigm, but I do think the rapid prototyping helps them, because one thing is, as I mentioned earlier, to know it like theoretically on your mind, yeah, this is like that, but then a different thing is to really face it on your system and see, so why is this component not progressing? So why didn't I get the answer that I expected, and what do I do if I don't get the answer, and what if the answer gets delayed, and how much delay is admissible, right? All those questions and answers. For the rest, yeah, as I said, it's more approachable. The Elixir community is friendlier. It's very prolific in learning resources, in very good quality learning resources of all levels, I dare say. And well, it's probably the situation is probably that Erlang has somehow catched up in the level of tooling that helps programmers. But there was a time, probably around the time that I choose to make the change from Erlang to Elixir, that the tooling was very newbie friendly at the time, also for Elixir compared to Erlang. Everything else more or less stayed the same. So we can argue it was a small change from Erlang to Elixir, but it was a meaningful one. And again, the tricky parts of using FP as a tool are not really related to FP. So probably those would be my headlines. So if we have to sum up, and I have to give you like a couple of headlines to take home with you. This is bold, but I will stand by this. I think that the Erlang ecosystem, the Erlang Elixir ecosystem, the Beam, is still the best choice that I know for rapid prototyping of architectural choices. So if you yourself have to decide, so should I don't know, go for peer-to-peer for that particular problem, or what will work best, a pipeline with this structure, or a layered choice, or would a microservices against a little worker give me anything that I have not been able to grasp yet? Well, you can have the time for it. I will say go for it. Try and rapid prototype that in Erlang or in Elixir, and you will see. You will be able to have really, really fast a small thing to play with. So that works for me and for my students. So I stand by this claim. And I think what's behind that is what I was saying earlier, right? So it allows you. So in software architecture, I want you to think asynchronously, because as this relates to, again, to Robert talked yesterday, the world is concurrent. And the world is asynchronous as well. You cannot really sit and wait for others to do things that you depend on. And you cannot really design your system that way. You have to think it over with different assumptions. And that works with this ecosystem. It's a really powerful and easy tool to use to train that mindset. And also something that I haven't mentioned yet, but it should be at least taken into account. It's also the fact that the abstractions in the language, Erlang, Elixir, so the fact that you have lightweight processes and the motto. I'm not sure if we've used the motto during functional conf this year a lot, but you probably heard of the just let it crash. That's a phrase that we use a lot in the Vim community, and what means is that if you shouldn't try to design the business logic of your processes taking into account all the wrong things that can happen. And that's something that the students are also, they have to fight against that urge. So yeah, first they have to remember that in functional program, you use pattern matching and you don't use the if so often. So you move to your functional closest to the definition of your functions. Actually, that sort of first filter of what I'm getting from the outside world and what I'm going to do with it. But you shouldn't be really, you shouldn't work wide on everything that I have, every kind of input that I should be able to get. And if it's not like this, then I do this error. And if not, no, that's like really defensive. Now you focus on the really processing the kind of input that you're prepared to work with. So the happy path, that that's also something that we use a lot, right? The happy path. You focus on the happy path. And if there's something wrong, your input doesn't comply, or something that should happen didn't happen, or whatever, you name it, then you fail. And the language has a number of structures that it has supervisors, supervision trees, and a number of mechanisms that help you, encourage you to separate your business logic from your error management logic, so to speak. And that is also very helpful. Perhaps not so visible or not so profitable within the span of 15 weeks, because it's the kind of thing that will pay off in maintenance time through time. But again, it's a good practice, and it's also a skill that they have to develop as software architects, to have those concerns separated. And again, it's something that they already know, because from the design course, they already know that separating concerns is a good design practice, but sometimes they think about that only in terms of functionality. So yeah, I should separate my, I don't know, user management from my product management. That should be two different entities, two different subsystems. Yes, but within each, logic management and error management are intertwined. And well, this is a plus, right? That's another level of separation of concerns that they learn to think of. And well, as I said, the rapid prototyping really works also when they want to go beyond one node. They want to really be ambitious and say, well, but our problem is going to run in a number of nodes, and that's not something that they have usually worked with in other courses that they have taken before. They do a number of courses in which they have to develop web apps in Java, Spring Boot, blah, blah, you name it. But they usually deploy them on a single machine. And yeah, they have like their application container, and they have their front end, but it's not really, they don't really grasp the difficulties and actually the also the thrilling of having different nodes in your system with different business logic deployed and different components that are living in one and the other, and the fact that you can kill one of them and see if the others are able to realize and to live on, and what happens if the node then reappears again. So that sort of thing is made easier, and they are really happy to afterwards to really have been able to play with that. But this is all intrinsic, right? So this all happened within Erlang, within Elixir, within the course. And before I finish, I want to discuss with you something else that I think is happening out there. Well, I have also left the link for another talk that I actually gave in CodeBeam 2020 about how the Beam, work with the Beam, helps you change your mind on how you think on systems related to all these things that I have just mentioned. So the other thing, and my final thought for this keynote, is there's something else going on in the world, I dare say. I think companies used to be more secretive about using Erlang back in the day. And it was really difficult for me as a teacher, because sometimes I knew, I mean, I went to Erlang factories and Erlang user conferences and co-beans, and I knew people working at this and that, and they were using, but then if you as a student will try and find companies that use this language, it was really hard to really even find job ads that you could apply for that had Erlang explicitly mentioned, right? But I think that's changing. And I think there are many more companies being visible and vocal about using Elixir, for instance. And that's as an instructor, as a professor, that gives me additional bonus points, so to speak. Because when I was using Erlang in this software architecture course, of course, after the 15 weeks, they will acknowledge, yes, this was useful, and this tool, this language that you made us learn, it made easy for us to grasp the things that you wanted us to grasp. But sometimes I had the feeling that it was just there, and that on their CV, few of them will eventually end up putting, I know Erlang and I did this with Erlang. because they didn't see in industry the interest for that fact. But nowadays, I think they do not think that anymore, because they do find Elixir and Phoenix, and we're going to talk about that in the next slide, out there more often than they expect. So this, well, the screenshot is in Spanish. I took it like, I think it was last year, but it represents in Google Trends the interest in Elixir programming languages. And of course, this was taken from Spain, so it might be skewed for this geographical part of the world. But you see that there's been a growth in interest, and around probably 2015, a spike that lifted up the interest in this programming language. And that is when Phoenix appeared. And if you have never heard about Phoenix, well, it's a web framework for developing web applications, and it's made in Elixir. And it became famous 2 years ago. I don't know if you've ever taken part or if you heard of the Stack Overflow developer survey. It's, well, rather famous. Almost 100,000 developers take place in the survey every year. And in 2023, Phoenix came up as the most admired web framework. So, but before React, before Node.js, which was kind of the things that people were using all over, this kind of small technology developed in Elixir suddenly comes up and scores #1 in that survey. And that was, well, that was a milestone. That was a turning point. So people started to hearing about Phoenix and consequently hearing about Elixir, and maybe they didn't use it, but they knew about it. And that also happened to my students as well. So it started happening that I had students on my class that when I said, we're going to use Elixir in this course, they were not surprised anymore, in the sense that they knew that it existed. And that makes a whole lot of difference in the attitude that they have when they have to learn this language. It's not only useful for this course because my teacher says so, but it must be useful because I've heard that out there people are using it. And well, then of course, later, last year in 2024, the survey took another spin because, well, the headline here was that Rust was the most admired, 83% scored. And that is this red 82.2 that you can see on your right-hand side. But then see what's second place. What's second place in the red dots is Elixir, which is at the bottom because it's not that much used, but it's second place. And it was not Phoenix anymore, it was Elixir itself as the second most admired programming language. And well, of course, that may have to do with the fact that it also came on the developer survey last year, or Stack Overflow, as the second most well-paying technology. And well, I'm not gonna lie to you. As a professor, I would really expect my students to have other motivations rather than money. But if money is one plus for them, and I can really use this as a motivator in my course, then I'm gonna welcome it. So yeah, that's it. So as I said, to take home, I stand by my claim earlier, and I will probably rephrase it to say I think functional programming is a paradigm that has a number of benefits that go beyond programming. This talk has not been about programming. This talk has been about software architecture, and I think the functional programming in particular, the Erlang ecosystem is it's a great tool for these concepts that belong to the software architecture level. The focus not only on FP but on concurrency and distribution that the big ecosystem has is, for me, has no competition in terms of pedagogical tool. And yeah, that's probably my bottom line for this keynote today. And Thank you very much for your attention. I hope you enjoyed it. I hope you have some food for thought. And I'm more than happy to take your questions, if any.
Thank you so much, Dr. Castro. We are out of time.